Bonding materials. The bonding materials must withstand centrifugal forces and high temperatures, must resist shattering during shock loading of wheel, must hold abrasive grains rigidly in place for cutting it, allow worn grains to be dislodged so new sharp grains are exposed. Vertified bond is a strong and rigid, generally utilized. Resinoid provide a shock absorption and elasticity. They are strong enough. Silicate provide a softness. Shellac used for making thin but strong wheels, processing some elasticity. Rubber bonds for making flexible wheels. Metallic bonds for diamond wheels only. These are the bonding materials. Next one is a vertified bond, strong and commonly used. Resinoid, silicates, softness, rubber bonds, metallic bonds. Grinding wheel specifications. 30A 46H6V XX. These are the symbols. XX manufacturer private marking for wheel, that means optional. Bond type B, resinoid B, F resinoid reinforced, E shellac. R rubber, RF rubber reinforced, S silicate, V vitrified. Next one is a V, the structure scale range from 1 to 15.1 equal to very dense structures. 15 equal to very open structures. 6. Grade scale range from A to Z. A means soft, M means medium, Z means hard. Next one is a H type. Grain size coarse equal to grid size A to 24. Medium equal to grid size 30 to 60. 46. Fine equal to grid size 70 to 180. Very fine grid size 220 to 600. A abrasive types: aluminum oxide, C silicon carbide. 30. Prefix manufacturer symbol of abrasive. These are the grinding chip. The grinding chip being produced single abrasive grain. Mentioned here. C. B. Workpiece. C. Abrasive grain. Note that the larger negative rack angle of the grain. The inscribed circle is 0.06 diameter, mm diameter. B. Chip formation, an abrasive grain with a wear flat. Note that the negative rack angle of the grain and small shear angle. Next one is a chip formation. Chips is the process are formed by the same mechanism of compression and shear as other machining process. As the grain or abrasive become dull, the cutting forces increase. The increases in the cutting force causes the grain to plow and rub rather cut. As the plowing and rubbing increases, the grains fracture at the cutting edges to reveal a new cutting edges.